Hi, good morning, students. I promised you that I would go over the review with you today, and so I'm going to do that. Again, I can't record for a whole long time on Screencast-O-Matic, so I might go over this a little fast, so if you need to go back and look at it again, please do that. All right, number one, what is potential energy? Potential energy, if you remember, was related to the object's position because the higher you are, the more potential energy you have, and the lower you are, the less potential energy you have. Kinetic energy, remember, was energy related to motion. All right, so we have the roller coaster. At which point does a roller coaster have the most potential energy? So if you remember, we learned this in class, where we have the roller coaster at its highest point, B, is where you have the most potential energy on the roller coaster. And then remember that as it goes down that first hill, it's going to gain speed, so it's going to cause it to speed up, which is going to give it more kinetic energy. What is a force? Remember, a force is just simply a push or a pull, sorry, not a pull, a pull, and it's measured in newtons. Okay, so this graph, remember that you have it starting off really, really slow because they are covering a short distance over a long period of time. If you're going slow, you're going to not cover very much distance over a long period of time. But as you'll notice, this line is going up, so they start covering more distance over a shorter period of time. So that means that their speed is increasing here. Next one. So this one is showing a constant speed, and then remember, when the line goes completely horizontal, that means that they stopped. Their distance stopped, but their time went on. And then they went back to where they started. They started over here, and they went back to where they started. So this is going somewhere, stopping, and coming back to where you started. This one is showing a constant speed. Whenever you see a 45-degree line like this, where they're covering the same distance over the same amount of time, that is a constant speed. This one is showing a constant speed, okay, going away from where they started, and then they stopped, and then they kept going away from where they started. So this would be like if Mrs. Pulver went to Walmart, she stopped at Walmart, and then she went on and went to Lowe's or Home Depot, wherever is actually open right now. Okay, so that's going to be this one right here. Calculate the speed. So I'm not going to be able to do this exactly on here right now just because it would take too much time, but please remember to use your calculator. You're going to divide the distance by the time. So 5 divided by 2 would be 2.5. Okay, that should kind of tell you the answer right down here. But remember that you're dividing distance by time to get the speed. Okay, so remember that right here you have Angie is doing an experiment at gravity. She drops a baseball down a ramp which is 18 feet long. Okay, there's my distance. It takes the ball 78 seconds to get down the ramp. What is the average speed? So you would take 18 divided by 78. Make sure you do that and you don't accidentally put in the time first divided by the distance. Make sure you put in distance divided by time. Okay, Sarah's running a race that's 3 miles long. So again, you have the distance right here. It takes her 15 minutes. So that's the time. So you're going to take the distance, which is 3, divided by the time, which is 15. And I'm going to give you a clue. If you're dividing something smaller by something bigger, you're always going to get a decimal point. Okay, you're always going to get less than 1, which is going to be a decimal point. Okay. On this one, using the graph to calculate the speed of the boy, the easiest thing to do right here is look at his total distance. So his total distance was 50, and his total time that it took was 5. So then you're going to take the total distance, 50, divided by the total time, which was 5, and then that should give you 10. Okay, this is what is the boy's speed like over the course of the race. So they want to know over this whole race, what was his speed like? Well, he was running at a constant pace through the race. We know that because for every 10 meters, he was going 1 second. So at 20 meters, it took him 2 seconds. At 30 meters, it took him 3 seconds. That means that he was going at a constant pace throughout the race. what kind of ramp that would take less effort to move something up it. So remember that the longer a ramp is, the less effort it takes to move something up it. You might have noticed if you go to a building like a nursing home, for instance, they're going to have a long ramp in order to get people in their wheelchairs up and down the ramp. They don't have short ramps because short ramps would take a lot of effort. The ramp that is longer is always going to take the less effort to move it up it. So you have to have a longer ramp, especially if you're trying to move something like a person in a wheelchair up it. Okay, which person on the diving board has the most potential energy? Again, it's the person who's the highest. So this person right up here standing at the top has the most potential energy because they're the highest on this diving board. What is gravity doing to this ball as it falls down the stairs? So gravity, remember that gravity speeds things up as they fall. So as this ball bounces down the stairs, gravity is causing it to speed up. That's why if you jump, somebody jumps off a tall building or out of a plane, they have a danger of dying because their speed is so high when they hit the ground. If they are not, if they jump off something less, then they're not going to be as tall. They're not going to be as high. They're not going to go as fast when they fall. Okay, the force that is opposing motion down the stairs and is making the ball slow down a little bit is going to be friction. So remember that friction, the air resistance, and also the friction between the stairs and the ball is a force that opposes motion. It causes things to slow down. Which force is the greatest unbalanced force? So their answer there is, of course, gravity. Even though friction is slowing this ball down as it bounces, gravity is still a greater force and it continues to pull the ball down the stairs. Which object has the greatest kinetic energy? So you have to ask yourself, well, which one of these is going the fastest? The boy, the ball, or the goal? So we're going to assume that the ball is going the fastest. It's flying through the air. The boy just threw it, and so our answer there is the ball. Okay. At which point is the cannonball speeding up because of gravity? Again, right here, it's going against gravity's pull. So gravity is slowing it down. Remember I said gravity is jealous. It wants you back. It doesn't want you to leave it. So it's going against gravity here. So gravity's slowing it down. But as soon as you start heading back, gravity is going to speed you up as you fall. Okay. So at which point is the cannonball speeding up because of gravity? You would actually say D. Right here is where it's speeding up because of gravity. At what point is the cannonball slowing down because of gravity? Again, you have, and actually you could answer A and B here, because as soon as this leaves and it's going against the pull of gravity, it's going to cause that ball to slow down because gravity's pulling on it and trying to get it back. At which point of the picture is the cannonball changing directions because of gravity? So right here, C, you'll notice that it was going up and all of a sudden it changed directions and started falling back down. So it's changing directions right here, C, because of gravity. What forces are acting on the cannonball as it flies through the air? You've got gravity is working on it because again gravity's pulling it down here, gravity's causing it to speed up over here, but you also have friction as it goes through the air, which is the wind resistance. The air pushes against the cannonball and causes it to slow down. Friction is always a force that opposes motion. It tries to get things to slow down. What is the greatest unbalanced force working on the cannonball is gravity. Gravity is the greatest unbalanced force working on the cannonball. Okay. All right. We're at the end. Make sure that you hit submit. We have several of you that I've contacted this week that have said, I did all the work. Why am I not seeing the grade? And that's because you didn't hit submit. So make sure that you do that. That will allow us to see that you did it and go in and check your short answers. Okay. Hopefully you guys are doing good. Remember that if you're in Mrs. Pulver's class, I said that we would do a Zoom session at 2 today. If you have any questions, go ahead and log into the Zoom meeting and ask me whatever questions you have. And then tomorrow you'll take the test. All right. Goodbye.